Hi everyone, I'm Antonio. I am the CTO and co-founder of a wallet. Let's simplify this in this way now, called FluidKey. And today we'll speak about how I see the future of privacy on any chain, especially now focusing on EVM chains. Specifically touching a new technology that has been brought back to life by Vitalik on one of his posts a couple of years ago, a little bit more. That was also a post that inspired us on building on this technology and will probably become one of the default ways for obtaining privacy on EVMs. First of all, a couple of questions to start, and you will understand why these are important. If I ask you what is an Ethereum transaction, I probably guess that, yeah, maybe you don't give exactly the same word as a definition, but we can come up with a definition that we all agree. It's obvious what is an Ethereum transaction, no? Now, if I ask you what's privacy, I'm sure that we will never agree over a single definition. Also because it's more like a broad concept, privacy. It depends, if you ask that question to a North Korean person, probably will say something that a Swiss person gives for granted as a constitutional right, that doesn't think about that as a privacy. Okay, so the environment, what's our goal, what we want to reach, define what is privacy for us. And in this broad space, privacy doesn't affect only transfer of value, monetary transaction on a blockchain, no? For example, on messaging, probably you all know this app is Signal, Signal, whatever you want to call it, is definitely the leader in privacy when it comes to messaging, okay? Even though the majority of the people use WhatsApp, forget about that. It's easier, it's a leader, and has worked well since 2014, like more than 10 years out there of the leadership, no? Again, for messaging, it's pretty easy. Two parties involved, I need to message another person. They're just a very simple encryption, no data to be processed across a lot of nodes that must be synced and so on and so forth. But when it comes to transactions, it's much more chaos. First of all, there are many tools, but none of this is a leader in the section. But the part that scares me most is that all of these tools are rarely used by most users, meaning that average user transacting on-chain doesn't put privacy in a position that matters to him, and rather just use only one address, and if I now want to transact with you and I know you in person, you will be able to see all my past history and all my net worth, at least on that specific address. Now, how can we obtain privacy today? There are two main ways of doing that. On the left, what's called privacy pools. Tornado Cash was not a privacy pool, but just to give you an idea, that's the concept around that. Okay, a way to break traceability. So I move money in, other people move all the money in the same contract, and then this money goes out on the other side, but the in and out are not connected. If I do it in the same second, yeah, I'm not super smart, but if I wait time, I don't know out of the money going out which connects to the money getting in, okay? They're easy to understand. We explain in a few seconds. UX is very bad. The user needs to wait a lot of time. There's a lot of multi-step to do on that. There is this thing called proof of innocence to prove that my incoming, my outgoing is not connecting to a malicious incoming transaction. Very easy from a mathematical perspective, but try to explain that to a judge over a case. He will never understand that because there's a lot of math involved. And it takes time. On the other side, there are stealth addresses. That's what we're going to talk about today. They provide anonymity, privacy through unlinkability. Just keep in mind this word because it goes against traceability, and we will deep dive on the difference between these two words in the next slides. It's compatible with any DApp. So stealth addresses, think about as a regular address. A lot of them, all of them controlled by the same private key, but if you look at them from a third-party perspective, so from outside, you cannot see that the ownership is the same through all these addresses, okay? It's not black magic. We will see how to do that later. They provide great UX. You don't have to wait time. You can interact with any app. The recipient doesn't need to be in the same privacy pool you are, also to transact privately with another person, and so on. Traceability is preserved. I put it in yellow because Sometimes it's good, sometimes it's less good. The traceability is preserved, and we will go also more in details later. So 2 ways: stored addresses, privacy pools. Focus on stored addresses now. This slide is, you probably have noticed that I put bad UX. The majority of the users will never move into privacy if the UX is bad. And I tell you this other thing. Forget about all the people that you know that are in the blockchain space. Go think to a person that in this space it's called a normie. Okay, someone that comes from the regular, normal financial world. Now, if you tell them that in crypto, like the default of crypto is no privacy, they would be like quite shocked. Because the advantage of going into crypto is self-custody. But into a traditional finance world, privacy, at least intended that if I pay you, I don't know how much money you have, that's given for granted. Like every transaction has privacy, looking from the eyes of a normie, let's call it in this way. No? Instead, in crypto, it's not. We have to build that into the system. So how does it look using stored addresses? Okay. First of all, solves the privacy in a way that traditional ways of solving privacy didn't do. So the traditional way was hide the balance, hide the transfers. Okay, stored addresses plays with the rules of blockchain. Everything is visible. Each address is a regular address. But each user has an infinite amount of those addresses, theoretically. Okay, so the user doesn't have all the balance on one place, has the balance on a lot of addresses, and we need a software, of course, to manage them. The same way you need a wallet, because I don't think any of us runs a raw transaction on the blockchain. Use a wallet. Can be as simple as a MetaMask, but there's a wallet under that. And so the privacy is obtained not for hiding stuff, but for keep putting stuff every time on a new address. So if you pay me, the payment goes to a new, freshly generated address with no history and no balance on that. Okay? Then the money stays there, and we will see how to manage that. Because the misconception is, oh, but then if I have to move all to my main address, you see the money going all in the same place. No, the money stays in all of these addresses. These addresses can be also smart account. This is what we do, for example, at FluidKey, and gives a ton more of advantages into that. In fact, the management of these addresses, you obtain a great UX if you give a good UI. Okay? There are other examples of a good UI. For example, Umbra Cache is another solution built on top of stored addresses that does that. So a stored address is a one-time address generated by the sender, and this can kind of confusing, and we'll go how it works, to privately send funds, hiding the recipient's identity on chain. This is another important concept. Stored addresses protect the privacy of the receiver, not of the sender. Okay? Because if I receive a payment every time on a new address, I am the receiver. The sender can send from his wallet with everything visible. It's his problem, not my problem. Of course, if both the identities use stored addresses, this fragmentation of assets is shared from both the parties, and also the sender is preserved. This is important because allows me that care about privacy, that want to use to stored address, to receive money from anyone, even someone that doesn't care about privacy and doesn't want to segregate his fund or use a new wallet that implement this technology. With this parenthesis around UX, and I had to do that, okay, on the why user experience is important and how that can be solved. I bring back the promise I made you before, speaking about unlinkability versus untraceability. Now, the unlinkability is enabled by stored addresses. Unlinkability means I have money on a lot of addresses that are not linked together, okay? It's fast. Again, spinning up an address is milliseconds. It's compatible with any counterparty, any smart contract on public EVM chains. This means that if with one of these contracts I want to borrow something, I can do. With a privacy pool, it's enough if I can trade any tokens, ERC20 specifically. Okay? It doesn't break traceability. Sometimes it's an advantage. We have customers saying, oh, we like that, because if my funds get mixed with malicious funds, it's a mess. In this way, my funds stays only in addresses that I, receiver, control. Never gets mixed with others. Shielded pools on the other side are slow, takes time. You have to put money in and wait a little bit of time. There's a limited set of operation. Like some of this now brings NFTs, but even that, the NFT has an ID connected to him. It's very hard to do that. But it breaks traceability. This means that if I want to break the traceability of $1 million payment I received, they are perfect. And we will see how these two concepts, and that will be at the end of our speech, are instead lies. Okay? But at the moment, we will focus on stealth addresses. Stealth addresses is a concept. It's like, I don't know if you're familiar with hashing. Okay, also hashing is a concept. Now, how do you implement hashing? There are a lot of different hashing functions. In the same way, there are different ways of implementing stealth addresses. The concept is that the user must have one key and control a lot of addresses with that key, while on-chain not having this connection directly visible. Otherwise, you merely understand who is the owner of all these addresses. Okay? The left way was the first one, was the one that Vitalik brought up, is part also of an ERC, the 5564, and it requires only elliptic curve cryptography. Very simple, very intuitive, has just one problem: not ideal for key rotation. This means that you start with a key, and you always have to keep the key. The day that key is compromised, you cannot use it anymore. The day you want to use a multisig, you cannot rotate keys in a multisig, and this is the big problem that comes out with this. The most modern way, and there's nothing in production, we are actually working on a POC and try to bring that in production as soon as possible, was also that a suggestion from Vitalik that came less than a year ago, was using the zero-knowledge technology and key stores, and it works great with multisig, also with passkeys. It has a lot of advantages. It just requires a key store. And we'll get into details later, but key store see as a place where, this key that I want to use to control all the addresses, I store in that place, and then with a ZK proof, I control all the addresses. Later, we will deep dive into these two. I think the easier one to understand at the beginning is the elliptic curve cryptography. Okay? So how does this work? The user has a private key, we said before. Okay? If you, and this is again elliptic curve cryptography, if you multiply the public key, the address basically, the public key, sort of the user, that's public. Anyone can see that, also the sender. For a secret, think as a secret as a large number, a number so large that cannot be guessed. Okay? You obtain the public address of the recipient. Now, this secret needs to be sent to the recipient, so the recipient can use the same secret to multiply his private key and obtain the private key that controls the same address. So in this way, anyone can generate an address that only I can control, because the private key is never shared with anyone, of course. Okay? Now, how this number is transferred between the generator and the recipient, this is part of the ERC we shared before. Different ways. You can public encrypt it on chain. You can either trust a trusted third party to generate this address for you. Okay? For example, FluidKey, this is how it works. It's the way it generates the best privacy. You have, as a FluidKey user, you have an ENS name that uses a technology of ENS called the off-chain resolver that allows us to, every time that ENS is queried, generate a new address. It's something not so famous about that, but the address is never published on chain, okay? But it's connected to an ENS. So if you pay me, just put my ENS in your wallet and new addresses pop up. If two people do the same, two different addresses pop up in the addresses. And FluidKey acts as an indexer for the end user. So the end user in his UI will see the balance as if it is in just one single address. Instead, under the hood, there are payments going every time to a new address, and each of these addresses generated has an associated secret. When the user wants to send money on his client, so fully self-custodial, we provide him which is the secret of the address, and he can move the money, of course, through our UI, okay? That's the simplification we do. Privacy, I bring on the concept again, must have a good user experience. Friction must be reduced, not added. This is why we use ENS. Because if I was asking a user to have the sender generate the secret, okay, you need a sender with a PhD probably to do that, or just force the sender to go to a specific page. We don't want to do that. Just use ENS. We want users, they should bring their off-chain habits on-chain, so give a way for them to do wire transfer, SEPA transfer, Visa payments directly from their account. This is, for example, what we do with FluidKey. Okay, you can just do a bank transfer right from your FluidKey account, or you can receive money like there. And self-custody makes a difference. Privacy is expected for a regular user. This means that when privacy is expected, they want probably to go in some sort of stealth address generation, and they would say, oh, I love it. Okay, but what if I want to rotate keys? Because I've lost my previous key, I want maybe a setup that allows me to recover keys or something like that, because again, users are used to go to the bank and just ask them for change them. And when they ask, with the system of stealth address you just showed before, can I rotate keys? The question is no, okay? But there is a solution, and of course the solution is the god of everyone, that's zero-knowledge technology. And this is very simple what I explained you before, how stealth address generation with zero-knowledge technology works. There is a place that's called a key store, where you store the configuration. Now, think about a multisig. Usually, you keep the configuration in the multisig. These are the signers. The configuration stays instead in this store, and the safe deployed points to a position in the store. Now, if this pointing is visible, everyone will see all the addresses that I've generated. If instead, in the safe, there is what we call the stealth init, that's the hash of the position and the secret, the same secret generated before. The standard is the same. You generate a random number that you need to share with the other user. Now, this hash hides something that can be proved in a ZK proof, but cannot be reversed. So I cannot see who is the owner of that safe, but the owner of that safe with a ZK proof can control that safe and move money out of that. And you have an infinite amount of that, with the benefit that if you change the key in one place, all the addresses you have will change instantly the configuration. Because changing this position will, if we want to be in details, change the root hash, and changing root hash makes the past configuration no more valid. I know it is one slide. I can speak 1 hour on that. Okay, I just want to give you the concept of how stealth addresses can be generated in two ways, and this is the future of stealth addresses. So to sum up, what's the future of privacy into that? Well, I think that the future, and this connects me to one of the slides before, is the combination of unlinkability and traceability, where each of us has not one address. Yes, he thinks he has one wallet, but under the hood there are a lot of addresses, and every time I want to break traceability, because I've received a lot of money, because I receive money that I want to show who I pay to, where this money is coming from, or whatever, I just have this money going through a shielded pool and go back again into one or more stealth addresses, always controlled by me. Okay, so the shielded pool is a mechanism hidden in the wallet with great UX to break traceability and then to bring it back to stealth addresses. So how can you help in this space? Well, if you want to use FluidKey, it's free, and we call it a kind of on-chain bank in terms for the UX it gives. It's fully self-custodial though. because you want to share feedback and make sure to spread the word. This is the QR code if you want to go on FluidKey. This is the team that's currently work on. You can follow us on FluidKey, same handle, Twitter, Farcaster, Telegram, or fluidkey.com. And thanks for listening. And if you have questions, I'm here to answer. Thank you.
Thank you so much. Thank you so much, Antonio. I see that one question came in during all this, and you did it great, and lovely with the little power of insecurity, because I use multi-chain myself many times different. So, isn't fragmenting address of funds reduce UX?
Say it again, sorry?
Isn't fragmentation of address of funds reduce UX and efficiency of things we can't do in DeFi instead of borrowing capital efficiency in Uniswap, Ava, etc., compared to having it all in one address?
Yep. A great question. First of all, for everything you do, like the majority of the things you do, no. Because these addresses, for example, looking at FluidKey are smart accounts. So if you want to pay someone, we compute the most privacy-preserving path of taking your funds from your stealth addresses and do that operation. Now, specifically in the question they were asking about borrowing, because lending, it works. For example, in FluidKey, we have a function called auto-earn. The addresses generated are generated with already a module inside, that's a permissionless module, that allow us to move your money into an Aave or Morpho lending pool. What does it mean? As soon as you receive USDC, you don't even have to open the app. We automatically spin up the smart account for you and move the money into Morpho. You will keep seeing them as USDC, but they will earn yield for you automatically. And if you need them, it's instant, you can move money back. When it comes to borrow, though, there's one address in charge of that, and until the protocols will start allowing through ZK proof to have multiple addresses controlling one position, still not possible. The only solution is either or move the money to all one address, reducing a little bit of privacy, or using the ZK or the still privacy pool solution I was showing before. So yes, one address is in charge of borrowing, but you can put more capital into that address, passing through a privacy pool and breaking traceability. And actually, this is what we're working on with Railgun to get a great UX into this setup, because the end goal will be keep the same capital efficiencies as you have now with one address, of course.
And we just got another question in. What do you think about privacy-focused blockchains like Aztec, for example?
The problem I see is that the solution is great. By the way, all the ZK circuit are built we are building with Noir that is created by Aztec. So we are very close to them. We speak a lot about these topics. The risk we see is that we'll take an infinite amount of time and effort to move the capital to that chain. Okay, so as today, still the most liquidity stay on mainnet, regardless the amount of work that was done by L2s to bring that capital into them. You know? And bringing even to another chain, we see that as a huge fragmentation. So what I see is like more these chains as a pass-through, or maybe the source where you store your key store, and that key store gets then propagated through other chains. So a roll-up to support privacy on chains, rather the chain where all the privacy will happen. Okay, that's my personal vision on that.
Well, thank you, Antonio. Do you have any more questions from the audience sitting here before I have a very annoying one? No? So I have a very annoying one because I work a lot in Web3 in the communities, and I deep dive into wallets. So you say you're changing the address all the time, because every time I look into it, at one point, 2 of 3 wallets out, you find a connection back to another wallet again. Is that something you're actually doing so you cannot track through multiple wallets over time?
So, of course, we don't break traceability. So if I provide you 3-4 wallets and you go back in time, probably with a Dune dashboard, something like that, you can find if there's a common source of truth. I was speaking about that with the CTO of Dune the other day, and we were just saying about that. What I think is probably for the communities is the right approach. For example, in FluidKey, we are dropping a score token to one of the many addresses the user have, and that can be farmed over time as no monetary value, is not transferable, okay? But this can be used by users to prove you that they are valuable user because they have a high score. This means they have kept a lot of money for a lot of time in Fluidkey and so on, without saying you how much money they have and how they have. So that can be like a way for communities. We got contacted for airdrops. Okay, just give me which are your valuable users and you can airdrop them because we know they are real users, just not the fake users, without asking them to provide, to share the whole net worth to us. So, yeah.
That's perfect. I just want to ask, because I work with airdrop hunters, and they always make the one mistake. At one point, they connect the multiple wallets. When they put into an exchange or when they go into somewhere, there is a connection in there. That's where I find them all the time, and I loved it. I use 16 hours on doing that sometimes.
Okay, makes sense. Again, spinning up every address is, of course, allows users to have a lot of wallets, have a lot of different identities under the hood. No, that's kind of also what we want for privacy. No, so yeah, I think that the right solution is always in the between of the two.
Well, thank you, Antonio.
Thank you.
Do we have any more? Because we are going into the next segment very soon. We have a little 4-minute break. Again, thank you, Antonio. A big
you.
hand of applause.
Thank you.